Good morning, everyone. Welcome to another session of ToloTalks. We've been doing this since, I think, the middle of April now. We started this thinking it was just going to be a couple weeks. We had a Tolo U that we needed to cancel, reschedule. I don't know when we'll have Tolo U again with the current COVID state of being, but in its place, we decided to start these ToloTalks. And so now we're at a point where we're looking for inspiration. And this one came from a white paper that we've had out on the website for some time. So if you want to look for that, click on white papers and search for literally the title of this ToloTalk, which is Pneumatic Rodless Actuators, Top 10 Sizing Mistakes and How to Avoid Them. A lot of you are traditional pneumatic distributors. We spend a lot of time talking about electric products, but pneumatic products are still a big piece of our business. And we'd like, when we were talking and creating this presentation, we were thinking, well, sizing mistakes, maybe it's more top 10 best practices with pneumatic rodless actuators. So our team today talking is Michael Witchen, which is one of our applications engineers, one of the guys that helps you when you call in looking for help.
I'm the one that brought up the weather.
Yep. Our typical Minnesota, we talk about the weather every single day. So, and Adam Farley, our Northeast Regional Sales Manager, and Dave Schmidt, our Central Region Sales Manager, and then myself, I'm Sales Support Manager for Tolomatic. So let's get started. Click here. Dave.
All right. Yeah, thanks, Teresa. Great intro. So yeah, as she mentioned, most of you have got quite a bit of experience in the fluid power market space, and you know, Tolomatic is also still very engaged in pneumatic products. And so, you know, one of the things that we see in certain applications and installations is overestimating the available air pressure. You know, a lot of plants and facilities guesstimate on what they have available, and oftentimes it's different at the line than it is, you know, directly off the compressor, you know, due to distance and so forth. And so you can see all the different components that every one of us is familiar with regard to a pneumatic system, starting from the compressor and going all the way out to the workstation. You know, so that distance can be quite expansive and extensive, and you can easily see a 5 to 10% fluctuation in air pressure from one end of that intake to the other end where the work is being completed. At Tolomatic, we do testing at 80 psi. That's the big dial gauge on the right-hand side. And on all of our pneumatic cable cylinders, band cylinders, all of our pneumatic product, we do breakaway testing and leak testing. And so the two smaller bobber indicators on the left do just that. I think the left hand, it's hard to tell in the photo, but the left hand is the breakaway pressure and the PSI that it's required to get the carriage or rod to move. And then the right hand bobber gauge is the leak testing, you know, and all of our pneumatic products exit our plant leaking at a half a cc a minute or less. Next slide. All right. Next thing that we see is, you know, a lot of people don't account for the dead length, or they look at what their working stroke length requirement is and not accounting for the dead length, and then they get an actuator that may be too long for their space available. So you want to make sure that you account for that dead length and what the working stroke is required. So if they say they need a 24-inch actuator here, and you back out the dead length of one of our band cylinders, they're only going to have a 16-inch working stroke available to them. So, you want to make sure you ask that question on the front end, what is the working stroke required, and then factor in, the overall length of the unit so that it fits. And keep in mind, if you use adjustable shocks, and we'll get into that a little bit more in detail later in the presentation here, but those do take up additional dead length as well. So you might need that additional length to accommodate the required stroke length for the application. So the third oversight sometimes can be choosing the correct bore size. This chart that's in here shows at different pressures. So let's say we've got 90 PSI available to us. You can see this chart is specific for the MX product, where you would have about just under 30 pounds of force available on an MXP 16, but you'd have over 400 pounds of force available on the 63. And so, a lot of times they think, well, bigger is better. Well, bigger might do the higher force, but it's going to do it at a slower speed. And so, you kind of got to take that into consideration as well, so that, for instance, if they need 100 pounds of force, you'd be able to achieve that at 60 PSI with an MX P40, but you would be at 80 PSI, you'd be able to achieve that at 30 with the MX P32. So you'd be probably pretty comparable at speeds in those two cases at those pressures, but certainly the 40 at a higher PSI is not going to be as fast as the 32. So. Next slide. We do also still have quite a product offering. There isn't another manufacturer in our industry that has all of these technologies available to the marketplace, from pneumatic thrusters with the PB series to the cable cylinders to the mag coupled cylinders, and then all the different band cylinders, BC2s, BC3s, BC4s, and then the MX series. So we continue to have the widest array of pneumatic product offering available in the marketplace. So next slide. And
All right.
I think transition to Michael. Okay.
All righty. Yeah. So another one of the major key elements you want to take into account when sizing up these pneumatic band cylinders, and this is kind of the case for a lot of rodless style actuators actually, is just the moment loading factors, right? So without accounting for these properly, you can see premature failure of the bearing system on the actuator or potential other issues as well. So the moment loads, those of you familiar with our sizing software have actually probably seen this with the electric actuators. It's very similar. So you're taking into account how those offset loads affect the bearing structure of that actuator. So you'll see we actually have some images and GIFs that we'll go through over the next and kind of identify all the different types of moments. So this being the MX is going to be that roll. So that's going to be that side-to-side movement. So if you have an overhanging load on one side of the actuator extrusion, it's going to result in pulling those bearings back and forth. So that's going to be one of the most key elements, most commonly known ones. So if you go on to the next slide, we'll see the pitch, and that's that front to back rocking. And this is often a major concern, especially in vertical applications. So any overhanging load is going to cause a much higher torque in that MY. And that's something that you want to be very careful of, especially when choosing what type of actuator to use. We'll get into more detail a little bit later on that as well. The next one is going to be our MZ, and this is that twisting rotation. So depending on the orientation of your actuator, whether that carriage is on top, whether it's on the side, whether you're working vertically or horizontally, all these are going to play into how the load is attached and what moments it'll create. So what we'll often suggest is to actually go ahead and use our sizing software if you're sizing up even a pneumatic application, just to determine exactly what size unit and what bearing structure is going to be best. And we're more than happy to help you walk through that process step by step if there are any concerns or questions. So if we go on to the next slide. Another major factor is actually the dynamic moment loads. So this is something that we don't necessarily see the same way in an electric application. So yeah, if you want to go ahead and play that animation, that's a good way to look at it. You'll actually see as you accelerate with a pneumatic, you're going to end up hitting a hard stop. Oh, sorry. As you accelerate with the pneumatic, you're going to hit a hard stop at the end of stroke, whether it be your pneumatic air cushions or your shocks. And while a lot of this is already taken into account when you're sizing up those moments, that impact or that dramatic deceleration at the end will affect, your overhanging moment or your overhanging load as well. And that results in a moment. And depending on whether we're taking into account, flow control and that velocity that we're hitting that end stop with, you can get a dramatically different moment, whether you hit that at 2 inches per second or 20 inches per second. So that's something we definitely want to look into. And there are various ways that you can account for that, but definitely make sure that doesn't go unnoticed. Moving on to the next mistake, and this is where that dynamic moment load actually comes into play, is understanding the difference between the average velocity and the impact velocity in an application. So if you're going 36 inches in 2 seconds, your average velocity is going to be about 18 inches per second, but that doesn't mean that that's what you're hitting that final shock with, right? So if you're accelerating and you're accelerating all the way up through the end of stroke, you're likely going to see that final impact velocity is closer to 36 inches per second. So if we don't necessarily take that into account, you can see some major issues with your sizing. Your pneumatic air cushions might not be able to handle the application. You may need shock absorbers, or you may have sized the wrong size of shock absorbers. Now, there are a lot of other factors that play into this final impact velocity. I mean, obviously, if you're carrying a heavier load, whatever pneumatic air pressure you have isn't going to accelerate that load as fast. You've also got the friction on the system, whether or not you're using flow controls. Yeah, what's your breakaway pressure? So just to get movement initially. So all those play a factor in kind of what that final velocity is and whether you're exceeding that average velocity by a small margin or a very large margin. Either way, that's something we definitely want to take into account so that we can properly size up those shocks and pneumatic air cushions. One example that we have that's I wish we had video of, but we don't, was a really long application. It was like an 8-foot long actuator, and there wasn't any backside pressure on that assembly. So when you hook up 100 PSI to a small load with a cylinder of that length, basically there's nothing stopping that if you don't have shocks on the end, and it basically turned into a projectile launcher. That piston assembly actually shot right out the back end of that cylinder. So we'll try to get video of that for next time. All right, and next slide, and I think we're actually handing this one off to Farley. So.
Yep. Hi, everybody. Thanks, Michael, Dave, Teresa. I'm just going to chime in here on a few of the things that Dave and Michael have been talking about, and this is choosing the right cushions and shocks, right? This is, like Dave said, your adjustments, making sure that, your load's applied correctly, right? If it's a light load, you're not going to need external shocks, a light version or a heavy version. The internal shock will be, the internal cushion will work fine. And again, that's relative to the load and then how you actually supply all your flow controls too, because that's a big part of how you're moving that load. And then when you want to do adjustable and fixed, these are all for basically more larger load capacity, large moments, faster. faster motion profiles where you really gotta stop the load. And then, you know, the other thing that comes into this, a customer that has to, they have a very, very fast application to meet cycle times. So, you know, applying the right shock is very important just to meet those times. All right. Next slide. So yeah, so we've, you know, you get into our pneumatic catalog. We have all sorts of great examples of how to look at how you're gonna, you know, apply cushions and shocks. These charts are really nice. Examples, this MXP50 chart, and it really gives you just, you know, where you're looking for the sweet spot. You know, this is, you know, relative to final velocity and loading. You know, you can look at this chart and give you a, you know, it's a good example of where you need to be relative to cushions, to the light load, to heavy load shocks, relative to load and speed. All right, very simple. They're in the catalog, right? Very simple selection from there. All right, next slide. All right, so Michael mentioned this, talked about some breakaway. This seems to be a big, you know, part of the pneumatic sizing is, you know, what's it gonna take to get this load moving with a pneumatic actuator, right? And with us, like Dave mentioned, we have a lot of product, right? So we have a lot of different moment capability units, you know, anything from N series solid bearing to our profile rails, you know, so that's like you're trying to get that recirculated bearing moving, so it's going to have a lot more friction to it. And then the same with like the B3, right? So the B3 is a lot more bigger. It's a stout unit, and it's got recirculated bearings. But when you do like a dual wraparound unit, you're going to end up doubling that breakaway requirement. All right. We have a lot of charts internally. We had a lot of help and support inside. So if you need these, if you need to dial in your application on breakaway, you know, call into us and let us know. But we've got some, we do have charts internal to give you more of a what you're going to need from a breakaway for us. All right, and then that'll help you size your bore, the correct bore in the valving and everything else in your system. All right, next slide. All right, this is always a topic at ToloTalks. Even when I was a distributor guy like yourselves, is running our solid bearing carrier. Yes, it is sort of like a BC2, but these bearing supports are trapezoidal, and they're not actually great for a vertical application. So the other thing about this that everyone has to know, that, you know, that this vertical on the trapezoidals, you really have to adjust your, you know, you have to adjust that load on this carriage. And you got to be careful about it. And if not, strongly recommend going to a profile rail. So any light loads are probably, real light loads are probably fine for this solid bearing carrier, but, you know, like we're saying in this little snippet here, you know, the profile rail is going to give you a lot better moment capability, and even a better breakaway to move the load. All right, and then, you know, when you add floating brackets to verticals, probably not a good idea, because that floating bracket really has no moment capability attached with it. It's really meant for a real, you know, it's a horizontal style applications as far as that goes. All right, next slide. So this is what I mean by adjustments. I don't think everybody, you know, they think that when the carriage comes assembled and it shows up, you know, at the customer, that it's ready to go. Well, you know, we don't know what the load is or where the load is being set, the center of gravity is on this, on your application. So it's always good to apply your load onto the carriage and then do your adjustments. So, you know, do your locks, you know, unlock the screws from the carriage, tension it properly. You might want to run it back and forth to see how much, again, the more you lock it down, you're going to cause more friction, and that'll cause, you know, your breakaway to be slower, and or your cycle time. So you want to have to adjust that accordingly when you get these guys, when you first set them up. All right, next slide. And then this is always a good one, is just, you know, your environment, right? Where is these things going? You know, we have a bunch of different bearing styles, as Dave and I mentioned before, and they're all susceptible to different environments. You know, if it's not just it could be a wet environment, it could be a contaminant, you know, it's a heavy dust. And in this case, this picture right here, this is actually an application that was done locally, and for some reason it was a rush job. And this is in a powder. These guys actually bag cement, so they do the dry product of cement in a bagger, and they were supposed to cover these. Well, as you can tell, they didn't cover these. So this is an MXP 63P, which is very expensive, and it's a profile rail. So the profile rail is open bearing, and this lasted 3 weeks with this guy. So we ended up doing they did a bellows type of a bellows kit on these things to solve the problem. But this is just a great example of something that can happen if the environment, you know, with environmental concerns. All right.
Adam, can I just chime in here on that? You
Sure.
know, and some of the larger sizes, we do have, as it states there, custom solutions. And so what that includes is for those bearing rails, the THK bearing rails that we incorporate into the MX product has some brushes and scrapers that are available for like the 50 and the 63, but those aren't available in the smaller sizes. So as Adam said, you really want to look at all options. You know, sometimes the B3, because the bearing is internal, is a better product. Sometimes a solid bearing is a better product. And sometimes, you know, BC is a good product as well. So again, utilize your applications engineers to make sure that your environment is thoroughly understood, and we get you with the right product.
And if we can't tell you the proper answer, we'll send you right back to those regional sales managers, and they know a lot.
Right.
So.
And we do, Michael. So
No, yeah.
So, you know, again, we can apply custom coatings. We can do bellows. You know, all you guys know that you can apply. I have a pulp and paper plant where we have, these are electric belt drives, but we air knife. So there's air knives along the carriages on each side, so they're constantly air knifing any of the paper products that are on there. So again, there are options to helping out on these environmental concerns.